Thank God there's only a few more weeks until spring break.
It's like 2 weeks, right? 2. I think it's 2. 3 weeks until the end of it.
That's where you just gave me a calculus one because I knew that one was
No, that's not it. Should check the sound levels. Yeah. We should have had Alex play his ukulele for the sound check. That would have been awesome.
like a light strumming pattern in the background.
I know
Yeah.
I have to. Why would I?
Okay, 6. You're thinking of using T procedure. Yeah, we did 1 through 5 in class. We're looking for Acrobat, right? We did 1 through 5 in class, so we just need to do 6 through 12.
Hey Riz, I got 2 more, remember that. Miles.
I don't have it. He does. He has something against Nacho. It's not.
He responds.
Oh, what is going on here? Great. Okay, so we can take a look at question 6 now. You're thinking of using a T procedure. Thinking of using a T procedure about the mean of a population using a significance level of 5%. You suspect that the distribution of the population is not normal and maybe moderately skewed. Under what conditions is it safe to use a T procedure? Okay, so do we have, remember there is the 3 conditions for normality. 3 normality conditions. One of these has to be true. True to use T procedures. Okay, so condition 1. Large sample. N is greater than 30. Right, now they don't say anything about the sample being greater than 30, so we can use T procedures for samples that are greater than 30 because the central limit theorem guarantees a sampling distribution that is approximately normal. Okay.
Wait, for large sample, is it greater than 30 or greater than or equal to?
It doesn't matter. Doesn't matter. Okay. So that's one way. Another way is if the population is normal. However, problem explicitly says that the population is not normal. Since the problem states the population is not normal, this does not apply, or maybe cannot. And the third way that it would be safe to use T procedures would be the sample is not distinctly non-normal. Gosh, there's a double negative thing again, right? Okay. Okay. In most cases, in most cases, we can use T procedures provided the normal probability plot is approximately linear and there are no outliers.
So really only one to be applied here.
So in this case, only 1 and 3 would apply. Okay, does that make sense for 6? This is kind of a review of the normality conditions, basically. Conditions for T procedures are the same as conditions for normality. So let's look at 7. Okay, an inspector inspects, okay, large truckloads of potatoes to, wow, what an exciting job, to determine the proportion of the shipment with major defects using the potatoes to make potato chips. Now that is a very, very poorly written sentence.
What's wrong with the potato?
Maybe it has 4 eyes.
Maybe it gets up and walks away.
Gets up and walks it. Maybe it's moldy.
Maybe
Maybe it's already sprouting or whatever that starts talking. Yes, maybe it starts talking to you.
yeah,
I think you should go see someone with that.
Okay, so unless there's clear evidence that the proportion is less than 10%, she will reject the shipment. To reach this decision, she tests the hypotheses. Oh, it's a she. Oh, lucky her. Great job. H naught, the proportion is 10%. The alternative is the proportion is less than 10%. So in other words, she's starting with the assumption that she is going to reject the shipment. Using the large sample test for population proportion, to do so, she selects a SRS of 50 potatoes from over the 2,000 potatoes on the truck. Suppose that only 2 potatoes are found to be major defects. What are the conditions for inference about a proportion? What conditions are violated? Okay, so we're looking for violated conditions. Just remember the conditions. The first one is SRS. Bold. Okay. Has this been violated?
No.
This is not violated. Why not?
Because she's did an SRS of 50 potatoes.
The problem states SRS of 50 potatoes. Okay, so not violated. How about independence?
No.
What would it be violating?
We haven't violated anything yet. We're trying to figure out which of the conditions are being for the inference test are being violated. So independence, that would be 10 times the sample size is less than n. So 10 times 50 that's equal to 500. That's definitely less than the 2,000 potatoes on the truck. So since there are more than 10 n potatoes in the truck, this condition is not violated. Okay, so the answer is must be normality, right?
If normality is violated.
Bold. Normality. So we got to remember the normality conditions for proportions. Great. First condition, NP must be greater than 10. NP is equal to, how big is our sample size? 50. How big is what is our value of P? 0.10. What's that equal to? 5. Which needs to be greater than 10. Less than 10. Okay. So this condition is not met.
Just fair.
Hmm?
In a panic or a phantom, even if any of the assumptions are like met, we still keep going, and then we say our conclusion or summary.
Yes.
We suspect them may be biased because it's just this is an error. Right?
Yeah. Okay, so we found the condition that's been violated. Our sampling distribution is probably not normal. Capital normal. Any questions on it? Let's go to 8. Okay. A random sample of 900 individuals has been selected from a large population. It's found that 180 of them are regular users of vitamins. Thus, the proportion of regular users of vitamins in the population is 0.2. What is the standard error? Standard error. Now, well, question 1. First question should be, is this a mean or a proportion?
Proportion.
Yeah.
You have jump on this one.
You definitely don't want to use the standard error for a mean here. That would be bad. Okay, so the standard error for proportion, do you remember what that is?
Square root of
P times Q over N.
The whole thing, right?
I'm sorry?
Oh, thanks, Mary.
Yeah. Which is equal to the square root. P is 0.20. Q is 0.80. What's our sample size?
100, 900,
180 of your regular vitamin.
9. It was 180.
900.
Oh, yeah, simple. 900.
There you go. Standard error 0.0133.
Wait, what was the, just so we have in the note, what was the standard error of the equation for the means?
For reference, SE for means, SC is equal to S divided by sigma divided by square root of n, or S divided by square root of n. Again, that's just for reference. That has nothing to do with this problem. Question 9. This is just definition, right? Rejected. Did we reject or fail to reject?
Fail to reject.
He's not rejected. Failed to reject, so that's a type 2 error, right? Type 1. Sorry, type 2 error. Or this is type 2 error. Failing to reject a wrong null hypothesis. Okay. For reference, type 1 error. Rejecting a true null hypothesis. Hmm? Okay.
Failing to reject a true hypothesis is not.
Hmm?
Failing to reject a true hypothesis is not.
That's a good decision. Question 10.
Almost done.
I can't believe we're almost done.
You should be like, oh yeah, by the way, calculus review, like 10 minutes after stats out.
Because
Okay. Major tire manufacturer claims that his shock absorbers will last for 5,000 miles. A consumer watchdog group claims that the actual mileage is lower. If mu represents the true average life of shock absorbers, what are the appropriate null and alternative hypotheses? Null hypotheses. They've already defined mu, so you don't have to define mu. That would be mu is exactly equal to 5,000. Remember, the null hypothesis is always going to be mu equals a number. The alternative hypothesis, therefore, exactly. Mu is less than 5,000. You know, maybe next year I'm going to start putting verses in the middle of these. Verses. Begin! Was that the epic rap battle? Begin! No. What is that squeaky noise? That's what I'm worried. I'm worried it's a rodent. Is it a rodent?
I don't think seabirds suffer from probably most likely a cockroach, but definitely not.
Oh no, definitely there's a rodent here.
What?
There's definitely a rodent that roams my classroom at night.
Oh, it's in every building.
No, because like Miss West said that like.
No, there's definitely, because I've seen, there was after a stats review.
What?
There was a bag of food left in the back, and then a rat got to it and like clawed it and opened and started eating out of it.
You saw the rat?
No, I saw the remnants of the. Yeah,
Did you leave it there for
the plastic bag was destroyed.
You should do a mouse trap.
They are to get to food.
Anything and everything.
I'd love to leave a mousetrap, but I can't.
Why? Now that janitor's coming here.
It's actually, I can't, I'm not allowed to lay traps of that nature. I'm told that I can't actually use like a real mousetrap because it's too cruel.
What?
What is
You're
this
getting
school?
rid of it.
Ida?
And I'm told that a glue trap is also too cruel.
But really, it keeps it.
But that's the humane one.
Sure.
The glue?
What do you do?
Okay.
Glue that would plastic, like you pick up the live.
You make one of those convoluted mouse traps out of Tom and Jerry.
I would love to make one.
There's
That's
nothing
actually my
against
dream.
it.
As long as it doesn't kill the rat.
I say there's nothing against it, then go for it.
All right, suppose you select a random sample of size 5 from a normal distribution, that's important, with an unknown mean and an unknown variance, sigma squared. The null hypothesis, mu equals 65, is to be tested against an alternative hypothesis, mu is greater than 0.65 at an alpha level of 0.05. The resulting sample mean is 68.25 with a variance of 9. What are the appropriate test statistics, rejection region, and conclusion? Okay, so we're going to have to draw for this. Let's start with a test statistic. No, let's start with a rejection region. Okay, so for the rejection region, I would recommend you draw it out. Let's draw a T-curve. Here's our T-curve. I should plug in the tablet if I'm going to draw. It's like, is my technology that messed up? T-curve, here we go. T-curve. Boom. And boom. Looks like a hat. Kind of looks like a safari hat, right? If I was British and on safari, I would wear that hat.
Are you still on
A what? Sombrero. No. No. Okay, so we said alpha is 0.05 right here. So we're saying alpha is 0.05. So that means here we need to have an area of 0.05. Okay?
Is this significance level always on the right side?
No. We know it's on the right side because we have a greater than here.
Oh, but if it was less than, it'd be in the.
Less, yeah, it'd be on the left tail.
And if it was two tail, they'd have to add up.
Yeah. Give me a minute for my calculator to warm up.
Oh, did you finally buy it?
Hmm.
You finally bought it?
Yeah. All right, so what are we using, a T curve or a Z curve?
Pretty sure you said T.
Because it's S.
T because they're giving you S. Good. All right, so let's do an inverse T. So that's distribution. Inverse T. Okay, so the area on the right is 5%. What's the area on the left going to be? 0.95. Very nice. And how many degrees of freedom?
4.
Four.
All right, so that gives me a T of 2.132. 2.132. Okay, so T equals 2.132. Okay. And let's turn that into a mean. Okay. So we have T, I should say sub 4, is equal to x bar minus mu over s over root n. 2.132 is equal to x bar, which is unknown, minus mu. No, what was mu? 65? S squared was 9, so s equals 3 over root 5. So let's solve that real quick. We have 2
Wait,
point.
I thought they gave us the sample mean, 68.25.
Oh no, we're doing something else. We're doing something
Oh,
else.
rejection.
We're finding for the rejection region. Yeah, exactly.
What did you just do?
Hmm? I lassoed. Okay, so let's go back to the calculator. 2.132 times 3 over root 5
Oh, that was supposed to be an hour.
plus 65. 67.86. Yeah. Okay, so we're getting this number right here. 67.86.
Do we need that number?
Yeah, for our rejection region. The rejection region are all values of x bar greater than 67.86. Or the rejection region are all values of t with 4 degrees of freedom that are greater than 2.132. This is actually an alternative way to do a test of significance. So in this version of the test of significance, we just need to find the rejection region. And then based on our rejection region and our test statistic, we can decide to reject or fail to reject. By the way, what is our X bar? 68.25. So you should see that we're going to reject our null hypothesis here because our X bar is in the rejection region.
If it was the
Isn't it
alternative
not?
No, anything, rejection is anything greater than 67.
wait, if
But 65 isn't greater than that. U was
60.
No. Sample mean is 68.25.
Oh, that's
Mr. Correa, if said the alternative hypothesis was less than 65, then the rejection region is all values of X
That are
bar.
less than, yeah. Okay.
So what's the 2 point?
Any questions on the rejection region? If you approach tests of significance in this way, then you notice all you have, you do all of the math here, and then you do all the math based on the rejection on the alpha level, and then you reject based on the value of X bar. The way that we do it is we do all of our math based on X bar, and we make our decision based on alpha.
If we have super rejection region, is the graph kind of drawing part of it? So it's like that's necessary.
I'm not sure that it'd be necessary, but it is, visually you should know what's going on. Okay, so that's our rejection region. The next part is the value of the test statistic. Okay. So test statistic. So we got T sub 4 is going to be equal to X bar 68.25 minus mu 65 divided by square root,
Wait, isn't it 3
yeah,
divided by square root?
3 divided by the square root of
I have a question.
5.
the one before that. Do we have to specifically say that we reject 68.25?
We're not actually there yet.
Oh, sorry, I thought we were not.
Yeah.
I just sorry. Good job.
2.422. And doesn't that kind of all work together here? Look, the test statistic, is our test statistic greater than 2.132? Yes. Decision? Reject. Isn't our X bar greater than 67.86? Reject. What is, heck, we might as well compute p-value.
This is a T distribution, you can use TCP, right?
Yeah, T sub 4 is greater than 2.422. You know that value is going to be less than 0.05 at this point, right? That's equal to I forgot what it was. What was it? 2.422?
Yeah.
That was 442.
363. Right? So all of this evidence, it all kind of works together. They all point to the same thing. They all mean the same thing. Miles?
Why is that sometimes multiply the p-value by 2 and sometimes
Yeah, multiplied by 2 for a 2TL test. Only time.
that makes sense.
Conclusion? Conclusion. If the null hypothesis was true, the probability of a sample with a mean as at least as extreme as 68.25 is 3.63%. Since our p-value is less than alpha, and by that we mean 0.0363 is less than 0.05, we reject the null hypothesis. We conclude that the true value of mu is greater than 65. Unfortunately, there's no context here, but that takes the three different parts of the conclusion that you need to do, right? Should we color code the 3 parts?
Yes.
First part. Second part. What color?
No, you might look too much.
Let's go green. Now let's go purple.
You like a really good purple. Like at the bottom.
That purple?
At the bottom. Same difference.
I don't like that green. I need a forest green. Forest. Dark green. There we go. Yeah, it's for us.
I'm kind of lost on how to find p-value. Or just do a one-time test.
It's just, well, take a look at what we have here. Our alternative hypothesis was mu greater than the number, right?
Yeah.
So for our p-value then, we're going to take our test statistic and make it greater than, or make T4 greater than our test statistic. Okay. So basically that means that on this sampling distribution, we're somewhere here.
Yeah.
Okay. Now that probability of from our test statistic to infinity is very low. 3.63%.
But how do you get that from here?
Oh, that number is from here. Let me screen capture this for you.
The fact that we got 68.25 with only a 3% chance.
One more time.
It says the resulting sample mean is 68.25, but the fact that we got her, that is like real
Oh,
only 3% chance.
One more time. I'm sorry.
So there was only a 3% chance of getting 68.25.
Yes, if the null hypothesis was true.
Yeah, but
That help?
I understand. I was doing
The key. Okay.
yeah.
Any other questions on 11?
So what happens if our conclusions and write-ups are not as detailed as yours? Does that mean that we don't get full credit?
Yeah.
Like, does that need to be like that to receive full credit? Or can I be,
It needs to have the requisite parts.
what if it's not like as well written?
I'm willing to overlook a little bit of not well written.
Language?
Yeah. As long as you don't write anything stupid
Can you write down the deadline?
or mathematically incorrect. Let's put it that way.
Can you write the deadlines for clarification?
Yeah, we'll look at that when we're done here. Okay, 12. And then we have requests to look at how to write a conclusion again. Okay, so we have find the value of the appropriate test statistic. Did we just do that?
Doing it again.
Or two-tail, that we did
What's
11?
two-tail though?
Oh, this is a two-tailed test. Okay. Exciting. Okay. Let's look at the rejection region again. T or Z?
T.
T. Yes. Okay. Really good point. As soon as you see the letter S,
It's T.
that's a T interval, right?
Yep.
Right. So let's make our curve. Hey, that's not bad. Okay. Our mean here in the middle is 58.2 with a t-score t sub 15 equals 0. Okay. Now our alpha is 0.05. So that means the area here is 0.05.
Wait,
Isn't
maybe
it the
point-
combined?
Oh, yeah, 0.25. You are right. You're right.
They're losing it.
The alpha level is 0.05. So the middle is 0.025. Or so each tail together, the two tails together must add up to 0.05. 0. What'd you put? No. Probably, since this is a two-tailed test, let's compute the left one first, okay? Alright, so this is nice.
You were bored, weren't you?
Okay, so we're going to get that t, right? So we're going to inverse t again. And we're going to inverse t 0.25. And I believe there were 15 degrees of freedom, right?
Yes.
All right, so that gives us this number. Let's clip that. Don't know. Well, I'm getting an error too.
You're failing.
One more time?
No, it's 15.
15.
Degrees of freedom. It's the T15 degrees of freedom. Why is it equal to 0?
Okay, so let's see. That tells me that this right here is negative 2.131. This is positive 2.131. Okay, let's get those those x bars here. Okay, so the first one is negative 2.131 is equal to x bar 1 minus the mean, 58.2, over 4.8 over root 16. Okay, that tells me x bar 1 is equal to negative 2.131 times square root of 4.8 over the square root of 16 plus 58.2. That gives me 55. And 60.76. That's x bar 1, x bar 2, yeah. Screenshot this.
The X bar only going 2 after the decimal? X bar is only 2 after it?
Yeah, in this case we're just going to use 2. Okay. Okay, so this tells me x bar 1 equals, what was that, 55.64? Maybe you should just write it all. 55.64, nah, never mind. 2.131 is equal to x bar 2 minus 58.42 over 4.8 divided by root 16. X bar 2 is equal to 60.76. Let's put that here. 58.64. 60.76. That is 55, thank you. Okay, so the rejection region. Region are all values of x bar that are less than 55.64 or greater than 60.76. this is analogous to values of t sub 15 that are less than negative 2.131 or greater than 2.131. Yeah.
Do we have to write both, like for X bar and for?
I would be very happy if you just did X bar.
Wait, so we have to write either of those or both?
Either of them are correct.
And which one do you prefer?
I think X bar kind of tells us more than
Is it giving specific numbers?
exactly. X bar is more in context.
And I don't need to remember analysis, which is good.
I suppose. All right, so that's our test statistic or our rejection region.
Wait, I wasn't.
Got a little bit more.
Why is there no multiple choice?
This is multiple choice.
It's just not.
Yep. They've been denuded of their answers. Not neutered, denuded.
I don't think that means.
Okay, what do we have next? We have the test statistic. Okay. So, test statistic, t sub 15 is equal to x bar. What was x bar? 58.2? 56.85, thank you. Minus 58.2 divided by 4.8 over square root of 16. I guess it's worth looking here. Is our x bar less than 55? No. Is our x bar greater than 60? No. That means we're going to fail to reject, right? Okay. That's our test statistic. What's next? P-value. P-value is equal to 2 times the probability that t sub 15 is less than negative 1.125, which is also equal to 2 times the probability that t sub 15 is greater than that, which is equal to TCDF. I forgot it. What was it? 125. E99 with 15 degrees of freedom. Times 2. Look at that gigantic p-value. No, 0.2783. That it? We're going to reject the null hypothesis. For reference, reject the null hypothesis. Okay. If the null hypothesis was true, the probability of obtaining a sample at least as extreme as 56.85 is 27.82%. Since p-value is greater than alpha, p-value is 0.2782, is greater than, there's no alpha given, so we'll use 0.5.
But it is zero.
It's not given, right?
It is.
Where? Oh, it is. We fail to reject the null hypothesis.
So when you were, yeah,
I'm sorry, where?
in chapter to fail, I mean to reject.
Oh, you're right. We're going to fail to reject. Our evidence. Wait, what did we write last time?
Wait, since we're failing to reject,
We
do not
conclude.
have evidence, right?
We conclude, or our evidence.
Wait, I thought if we fail to reject, we have evidence.
I'm sorry. I'm trying to keep everything as evidence. Our evidence supports or does not support the mean is greater or not equal to 58.2.
If we did reject, then we would have evidence to support.
Yeah.
the value of that.
We're going to go to that things to write for the conclusion. Okay. To write for the conclusion. Number one, you have to summarize the p-value in terms of the sampling distribution. Number two, state the statement of rejection, fail to reject, linked to the alpha level. Number 3. Evidence supports or does not support the alternative hypothesis.
Even if you fail to reject, number 1 stays the same.
Yeah. If you reject, that means the evidence supports the null hypothesis, the alternative hypothesis. If you reject, the evidence supports the alternative hypothesis. If you fail to reject, the evidence does not support the alternative hypothesis. Maybe I should write that. Reject, evidence supports alternative hypothesis. Fail to reject, does not support.
What do we need to know about beta and power?
You need to know that beta and power add up to 1. And then if you're given 1, you can find the value of the other. Because they add up to 1.
But they won't ask us to find beta.
Yeah. If the only way that you would be asked to find beta is if they told you what power was. It's the only way that you would be responsible.
Power is equal to.
The only thing you have to know is power and beta equal up to 1. And if you have 1, you can find out. They'll have to give it to you though.
Okay.
What is power?
You also have to know the ways of reducing beta,
He wants to know a definition.
which is the same thing as increasing power.
Wait, he wants to know a definition of what power is actually.
Power?
Yeah.
Power is equal to is the probability of not making type 2 error.
So basically,
Hmm?
That's making it type 2.
so increasing power, decreasing beta.
Mm-hmm.
Another way that you could conclusion, you say that for this problem, since the mean was not in between the rejection region,
5 miles.
Absolutely. But you'd have to make sure that you state what the rejection region is at some point in your problem.
like how we did it.
Yeah.
So, how do we
And
find out?
if both correct, what if I don't use the rejection region and
Either way. It's either rejection region or p-value. One of the two. You don't have to do both. Yeah. If you like the rejection region, you're free to use rejection region.
For our benefit.
Tell them to test like about it, or is it like with the either or?
What do you mean?
Like, is it going to consider as this?
Well, I'm saying what I mean to say is that if you're conducting a test of significance, you can use the rejection region as a tool instead of the p-value. Or you can use the p-value and not worry about the rejection region. Either way is fine.
So how do we find power?
How do you find power? It's 1 minus beta.
I'll just tell you one or the other.
Yep.
You don't have to worry about that.
Okay, we're gonna stop here then, I guess. If you have any questions, let me know.